In this video, we're going to use a process called elimination to solve a system of equations. And a system of equations is when we're dealing with more than one equation at the same time. These are the two equations that we're going to be working with in this example. And when we solve this system of equations, we'll be looking for an x value and a y value that will satisfy both of the equations. And another way to look at it is if we were to graph equation 1 and equation 2, we would get two lines. The point at which both lines intersect is the solution to the system of equations. So that's the x value and the y value that's going to be the exact same for both lines. Elimination is just one way to solve the system of equations algebraically. So what I'm going to do is I'm going to stack the two equations on top of each other. So the first equation is 2x plus 3y equals 5, and the second equation is 4x plus 3y equals 1. Now I'm just writing it directly underneath the first equation. And you should always stack your common variables and your constant numbers on top of each other. Now there are two unknown variables here. Do you know how to solve for two unknown variables in an equation? Well, in elimination, we're going to add or subtract the two equations together to eliminate one of the variables. But let's compare our variables. We have our x's and our y's. In front of the x's, there's a 2 and there's a 4. In front of the y's, there's a 3. The y in each equation has a coefficient of 3. And that's what we want. We want a common coefficient in front of one of the variables so we can add or subtract the equations together and eliminate it. So our goal is to right now eliminate this variable. We're going to eliminate the y. And notice how in both equations we have a positive y. So if we want to add these two equations together, well, 3y plus 3y, does that give you 0y? No, it doesn't. But 3y minus 3y gives us 0y, and that's exactly what we want. So we're going to subtract these two equations together. And when we subtract two equations together, we need to subtract everything. So that means we're subtracting our constant numbers and our terms with x as well. So we need to do 5 minus 1, and that's just 4. And we're going to line up our equal signs below. And we know that 3y minus 3y, well, that's just 0y. So we've eliminated the variables because 0 times y is just 0. So this is pretty much gone. And 2x minus 4x is just negative 2x. So if I rewrite that without that 0y, we're just left with the equation negative 2x equals 4. So we've eliminated the y and we're just left with an equation that has one variable, x. So this looks like an equation that you should be able to solve. So how would we solve for x? Well, x is being multiplied by negative 2, and we can just do the opposite. We can divide by negative 2. And 4 divided by negative 2 is just negative 2, so x is equal to negative 2. So we found our x value, but we need to find our y value because there's two parts to the solution. There's an x and a y. So since x is equal to negative 2, we can substitute this negative 2 into one of our original equations. So I'm going to substitute x equals negative 2 into the first equation. And it doesn't matter which equation you choose, you should get the same answer. So equation 1 is 2x plus 3y equals 5. So since x is equal to negative 2, I'm just going to replace x with negative 2. And now we're just left with one unknown variable in this equation, and that's y. So we could just start solving for y. So 2 times negative 2 is just negative 4 plus 3y equals 5. And we need to get rid of this negative 4 that's on the left side of the equation. So we're going to add 4 to the equation. And when we add 4, we're going to be left with 3y equals 9. And since we're just left with 3y equals 9, if we divide by 3, we'll be left with y is equal to 3. Therefore, our solution to this system of equations is just negative 2, x is equal to negative 2, and y is equal to 3. And now it's your turn. Here's another system of equations. I want you to pause this video and try solving this one on your own. When you're ready, come back to the video and we'll go through the solution. So I hope you're coming back to the video to check your answers, but I'll go through the full solution with you. So I've already just stacked the two equations on top of each other. In front of the x's, there's a 4, and in front of the y's, we have a negative 5 and a negative 3. So since in front of the x we have the same number, that's the variable we're going to eliminate. So we need to either add or subtract the two equations together to eliminate our variable. So if we add them, 4x plus 4x equals 8x, and that doesn't work. But if we subtract them, 4x minus 4x is 0x. So we need to subtract our two equations from each other. And we're subtracting the whole equation, not just the x. So we need to do 7 minus 5, and that's 2. And we need to bring down that equal sign. And then negative 5y minus negative 3y, well that's just negative 2y. And 4x minus 4x is just 0x. So we've eliminated our variable x, and we're just left with the equation negative 2y equals 2, and that's a really simple equation to solve. We can just divide by negative 2 to get rid of it, because we want to isolate y. So y is equal to negative 1. But we're not done yet, because we need to solve for the other variable. So let's substitute y equals negative 1 into one of our original equations. And I'm just going to choose the first equation. So the first equation is 4x minus 5y equals 7. And we're just replacing that y with negative 1. And we can start solving. So negative 1 times negative 5 is just a positive 5. And before we get x on its own, we need to get rid of this plus 5. So we're going to subtract 5, and we're just going to be left with 4x equals to 2. And to get x on its own, we're going to divide by 4. So x is just equal to 0.5. Therefore, the solution to this system of equations is x is equal to 0.5 and y is equal to negative 1. Here's the next question, and if you're feeling confident about elimination, try the rest of the questions on your own, but if you need another example, just continue watching. So I've already stacked the two equations on top of each other, and if you look at our variables, we do not have the same number in front of our x's, but in front of our y's, there's a 2. But one's negative and one's positive. So we need to either add or subtract the equations to get rid of our y. So remember, our goal is to have 0y. So if we add these two, negative 2y plus 2y, do we get 0y? Well, we do. So this time, we're going to add the two equations together. And remember, we're adding the whole equations together. So negative 19 plus 1 is negative 18. And we bring down that equal sign. Negative 2y plus 2y is just 0y. And x plus 5x is 6x. So we're going to be left with the equation 6x equals negative 18. And it's a really simple equation to solve. We're just going to divide by 6. So x is equal to negative 3. But we're not done yet. We need to find out what y is equal to. So we're substituting that x value, x is equal to negative 3, into one of the original equations, and I'll just put it into the first equation. And we're just going to replace x with negative 3, so this is just going to become negative 3 minus 2y equals negative 19. And we need to get rid of this minus 3 before we deal with our y's, so we need to add 3. And when we add 3 to our equation, we're just left with negative 2y equals negative 16. And to get y on its own, we're going to divide by that negative 2. So y is equal to a positive 8. Therefore, our solution to this system of equations is x is equal to -3 and y is equal to 8.